Hello everyone. In our last video named Stata for Beginners, we have seen how to enter data and the different windows of Stata and how to use them. Now today we are going to talk about very basic commands of Stata and how to use Stata for our data analytics. So to start with, we would like to tell you that in the last video, we have seen how to save the commands as well as how to save the data. Now, the one thing that was missing, we had no idea how to save our output. So we would start with that. But before that, I would like to bring some data for today's illustration. So to bring this data, I would like to inform you that in every Stata, there is one inbuilt data for illustration purposes. We'd use that data here. So this is the data for automobile industry of 1978. So to use data, we want to write one command. So the command is use. So the command is use, and then we would write auto.dta, and this is applicable in all forms of Stata. So whatever versions you are using, you could use this inbuilt data for your purposes. So use space auto.dta. Why I have written .dta? .dta is the file extension for data file of Stata. So after writing this, you could click enter, then it would come, the data would come. You could see there are 74 observations and the file size and the properties of the variable. The default variable is make, and you could see the properties of it. If you click on any other variable, you could see the properties are given there. So apart from this, you could see in the review window, the only one comment that we have written, it's coming here. So if you would like to take the same comment, you could click over here and the same comment would come in this comment window. Let's see, I'm clicking here, it has come to the comment window. Okay. Now we would see how we could save the output. But before that, I would also like to inform you that you could see these variables are there along with this label. What is labeling then? Labeling is, suppose Mr. X has entered the data on behalf of me and I'm working today with this data. So Mr. X has used the variable name of his own choice. So I don't know what actually this name represents, like MPG, what does it mean? It's not clear to me. But this labeling would help me. If this is properly labeled, I could get that this MPG actually stands for mileage per gallon or something like this. Similarly, you could see for other variables, like it's written as foreign. I don't know what foreign actually mean. So you could see it's actually car type, whether the car origin is foreign or domestic, the variable represents for that. So now we would see how to save the output. So as you have seen .dta, let me clarify one more thing here. Okay, .dta stands for data file extension for Stata. Similarly, for do file, whatever you would like to save, it would be saved as .do. That is the file extension of do file. And similarly, if you would like to save the output, the extension would be .essential. We would see that. So for that reason, we need to go to file, then you have to come to log, and then you have to begin the log. So then a window would open that would actually where you would like to save your output. So we would like to save the output in D folder, in the D drive in the data folder, and we would like to give the name as demo, and the file format is .essential as I was talking about. Now we would save it. It's okay, it has come. Now after this, we would move to You may ask, where is the output? But I would like to show you. Okay, here if you open the same folder, D drive and the data folder, if you open demo, so we have not worked anything. So only this portion is saved so far. So we would see, okay, what would happen after working with this data for some time. So the very first command I would like to tell you is only D. D stands for describe. It would actually describe my data. So that means, okay, what is the number of observation, how many variables are there, what is the size of the data, and about the different variables and their type would be described by this command. So now if we click enter, we could see that the outcome has come as contains data from auto.dta and observations, variables, size of the file, and the different variable type. So to understand about this variable type, let me talk more about this variable type first. So if I go to data editor, we could see there are three different colors in my data set: maroon, black, and blue. So this maroon is actually stands for string variable. Whenever any variable is marked as maroon, you should actually treat this variable as string. So you could see the specification is also given here that it is a string variable of 18 digit. Okay, then you could see black, but in this black there are two type of variables also. First one is in decimal points and another one is in whole numbers. So if any variable is in whole number, it is called integer, and if any variable is in decimal points, it's called as float. So sometime we would like to actually rename our different observations of a variable. So if we do that, we would label these variable different observations of a variable, then this variable would come in blue format. So if you look, this foreign variable, it has two outcomes, domestic and foreign. So domestic, this observation is given as 0. So if you click any domestic observation, it is coming as 0. You could see the value of the variable here. And if you click on foreign, you could see the value is equals to 1. So this is in byte format. So you could see that this is in byte format. So from here, we could make an idea that what type of variable we are using for our analysis. So this is also given here, okay, with a string, integer, float, or byte. Okay. Now after that, we would introduce another command, but it has very limited applications, but you should know about it. The command is count, C-O-U-N-T, count. Count would actually give us how many observations are there in my data set. So if I click enter, you could see 74 is the number of observations. Already from these data properties, you have already seen that we have 74 observations. So it has very limited applications. But the next command that I'm going to show you, it has a huge application. The command is tab or tabulate. So if you click, if you write TAB, then space, then any variable, it would, suppose I'm here using the variable headroom, and then enter, you could see for different observations of headroom like 1.5, there are 4 number of observations, 2.0, 13, like this, 74 observations are distributed like this. This is the frequency, this is their percentages, and this is the cumulative percentages. Cumulative percentage means this is 1.5, 5.41, 2.0, 17.57. So if you would like to know, okay, how many cars are there with headroom size less than equals to 2.0, so the percentage would be 22.97% of the total cars have a headroom size equals to less than equals to 2.0 size. Okay, so this is the application of tabulate command, where you could get the percentage distribution of it as well as the cumulative percentage distribution. So if you would like to know whether you could use this particular command for cross tabulation or not, I would say yes, it's possible. You could use two variables together to to study the cross tabulation between these two variables. So suppose I'm using headroom as well as this foreign variable to study the cross tabulation values for different headroom size and their origin of the car. So here in this case, after writing this command, when I have pressed enter, I have got this table. You could see 1.5-inch headroom size. It has 3 cars from the domestic origin and 1 car from the foreign origin, and total car of this segment is 4. So you have already seen in the last tabulation that the total 1.5 headroom size is 4 cars are there. So this is the cross tabulation. But most of the cases, we are not interested about these actual figures. Specifically when our data size is too big, like we were working in thousands or lakhs observations, say 1 lakh, 2 lakh, 3 lakhs observations, then these actual figure hardly make any sense, or it's very difficult to compare. So in those cases, we use percentages, that what is the percentage of car coming from domestic origin of headroom size 1.5 inch. So in that case, what we could do, we could use, or we could modify this command a bit. After writing the same command like before, tab space headroom space foreign, then we would put a comma and we would write row, ROW. That means we are asking for row percentage, and then enter. So you could see along with your frequencies, we are getting the row percentages. That means 75% domestic car have, of all the cars with headroom size 1.5 inch, there are 75% cars from the domestic origin and rest 25% from the foreign origin. So suppose you are not interested at all with these row frequency, row percentages. You want to know, okay, out of the total domestic cars, how many have 3.5-inch headroom size? So in that case, you want column percentages instead of row percentages. So you need to modify a bit. Instead of row, you need to write the command like before, tab space headroom space foreign, then comma, then space, then instead of row you need to write col, C-O-L, and then enter. You could see the column percentages has come along with these frequencies, and the required answer is 25%. That means out of total domestic cars, 25% have a headroom size of 3.5 inch. Okay, now sometimes for our research, for our study, we want both row and column percentages together. So what you have to do with this column percentage, you need to add row percentages as well. So if you have to write tab headroom foreign comma row space col and then enter. So you could see along with the actual number of observation, we have the row percentages as well as the column percentages. Okay, so in this way we could get the row percentages as well as column percentages for the data. Now sometimes we are not at all interested about these actual observations. We want only row percentages or only column percentages or only row and column percentages, but we don't want frequencies. So what you could do, you have to modify a bit. Okay, in the earlier case, you used to write row, that is tab headroom foreign comma row. Then you have to add another command, that is no freq. this is the specification I'm doing. Okay, I don't want any frequency. That is why I'm writing no freq and then enter. You could see it giving us only the row percentages. So you should be cautious about the specification. The spelling is NOFREQ. Okay. If you use this command, the specification with column, it would also give you only the column percentages. It would also work with row and column as well. It's coming row percentages and the column percentages together, but there is no frequency at all. So this was our discussion about the tabulate command and the various specification. Now, along with this, we should understand another important command, which is summarize command, or we could write it as sum. This particular command would actually give us the number of observation, the mean value of the variable, the standard deviation of the variable, the minimum value of the variable, and the maximum value of the variable. Suppose we would like to study the summarize value of price. So now with sum price, after sum we are writing price and we are putting enter. So you could see price variable has 74 observation. It is the mean of it. It is the standard deviation, and the minimum value is this, and the maximum value is this. So this is about sum command. But sometime for our study, we are not interested about the minimum value and the maximum value of the variable, but we are interested about the 95% confidence interval for this particular variable. So in that case, the command would change from sum to CI, that is confidence interval. C stands for confidence, I stands for interval. CI price, and then enter. So you could see 74 is the observation, mean value is the same, standard deviation. You could see the difference between the standard deviation. Why is it so? For this, we need to actually understand the statistics. We discuss it in our other videos. It's not our part of discussion here. So here you could see the confidence interval, that the lower limit of confidence interval and the upper limit of confidence interval is given here, and this mean value lies between this lower limit and the upper limit of it. Okay, so apart from this sum and CI, I would like to show you another important command or specification. Actually, after sum, writing the variable, you could include with the sum variable, you could sum command, you could use more than one variable. Like with sum price, I'm including another variable, say mileage per gallon, and enter. You could see for both these variables, the observations, mean, standard deviation, and the minimum and maximum values coming. But if you would like to know more about a particular variable, more characteristics like what is the median of it, what is the different quartiles of it, what is the different percentiles of it, what are other observations or other statistics of it, like skewness, kurtosis, what you need to do with the sum command, you have to write detail. That means sum space variable name comma then detail. You could see the outcome has come 1 percentile, this is the value, 5 percentile, this is the value, 10 percentile, 50 percentile. That means when we are talking about 50 percentile, that means this is the median. And you could see number of observations, and then mean value, standard deviation, variance, skewness, kurtosis. All these are available with you. So with this very simple command, you could study the basic descriptive statistics of any variable. So let's see, we had started our log, how it has worked. But before that, we would like to stop the log first. So to stop the log, you have to go again to the file, you have to go to log, and you have to close the log. So it would close your log with some time and date. So now we would like to see, okay, whether our data has been saved properly, output has been saved properly in the SMCL file or not. So if you click here, you could see we have started the log, and then we have studied the D command, and then count, then tab, and these are the outputs. All the outputs that we have run in the Stata, all are saved here along with the date and time of the variable. So if you want, you can relog any SMCL file again. So I think it was useful for all of you. We would end here, but before that, we would like to tell you, okay, if you like our video, please like and share. And if you like to learn more and to get more such videos, please subscribe our channel. And that's all from our side. Thank you so much. Stay healthy, stay safe. All the best.